is very high, and film thickness is reduced to very, very low level. And you see, the film thickness is very important. Why I'm saying important? Actually, it is not the IL film thickness we should consider. We should consider the critical film thickness. So let us first understand what is the critical film thickness here. Critical film thickness is nothing but it is the ratio of you can say the thickness of the lubricating oil film to the average roughness. So thickness of the film, lubricating film, divided by average roughness. And it is ideal to have at least 1.5, more than 1.5, this critical film thickness. If critical film thickness is 1.5 or 2, then what will happen? There are very few chances to have asperities direct in contact. And if there is no asperity direct in contact, you can understand the contact. It can be a line contact, it can be a point contact, line contact, maybe surface contacts. And as the contact nature changes, the sliding friction will change. So coefficient of friction here changes because under the load, if the film thickness is very, very less, what will happen? The asperity will be in direct contact, or you can say metal to metal contact, which is in general avoided by way of using the lubrication. So if the lubrication is not such that it is avoiding the interaction of asperities on the two rotating surfaces or two matting surfaces under the relative motion and the load, then there are chances of the deformation on the surface asperities, and that will lead to the wear and finally the failure of the component. So these Strivek curve is to be understood in a good way. So the zones of Strivek curve, as I said, there are 3 zones: a boundary lubrication zone, mixed lubrication zone, and the third one I am combining together as a full film lubrication. As I said, full film lubrication is just in 2 forms. One is elasto-hydrodynamic lubrication, and then hydrodynamic lubrication. Elasto-hydrodynamic lubrication is similar, very similar to the hydrodynamic lubrication, but it occurs only when the surfaces are in the rolling motion relative to each other. EHL gets its name as its name is elasto-hydrodynamic. So the film will be elastically deformed and causing the two surface of the matting surfaces separated, and that only the IL film is getting sheared off at the time of transmission, energy transmission or power transmission. So the film layer here is elasto-hydrodynamic. Right? This results in greater pressure on the film. So you see, whenever there is a asperity in contact, what will happen at the contact point or contact line? There will be a generation of very high level of pressure. We call it extreme pressure, and under that extreme pressure, a lot of deformation will take place, because extreme pressure will cause the deformity of the asperities, maybe plastic deformation, or maybe because of excessive heat generation, there will be a change in the microstructure and micro hardness, softening of the material, and in turn it will be causing the wear of the particles. So if this elasto-hydrodynamic lubrication is there, it will take care of those things. So hydrodynamic lubrication and elasto-hydrodynamic lubrication, here I am considering both as a full film lubrication. So let us understand these things in a little bit deeper way. So boundary lubrication, as I said, solid surfaces comes in direct contact, load supported mainly by the surface asperities, and there is a very high value of the friction. So coefficient of friction will be very high in this case, and it is because the load is very high and the solid surfaces are, their asperities are in direct contact. So when it will happen, take the case under certain condition, such as shock loading, or maybe heavy loads, high temperature, low speed, and critically low viscosity. These are the reason to go into this zone. So the lubricant is no longer hydrodynamic. So when the lubricant is no longer hydrodynamic, that means it is into the domain of, or into the mode of the boundary lubrication. take the case here. So whenever we are starting any engine, at the start point or at the end point, you must be knowing that when we are starting, the pump is not pump is not started earlier. So what will happen? There will be a less chances of a full film between the crankshaft and its bearing, or the big end bearing, or maybe the main bearing. So during the start, or maybe during this stopping of the engines, this boundary lubrication comes into picture, because at that time the load is very high, and because the crank is rotated from the rest, from the zero velocity to some velocity, so there will be a shock also, and load is there. So because of that, the asperities of the two crankshaft as well as the bearing, the two asperities will come in contact, and film is not sufficient. I mean, the critical film thickness is not sufficient. So in that case, what will happen? There will be a direct contact between the surface asperities. So this is one area. Then frequent contact between surfaces, resulting in a significant rise in temperature, because once the asperities starts interacting with each other, there will be a lot of temperature rise and the subsequent destruction of the contacting surfaces. So these asperities gets deformed and causing the wear. So under these circumstances, the fluid film is no longer capable of adequately protecting the surface. So this is required to be addressed whenever we are designing the lubricant. And the lubricants are fortified with some additives. We call it EP additives. So EP capability or extreme pressure capabilities in the lubricant are very, very essential to avoid failure of the component under boundary lubrication. Another, when we move from boundary to next, that is called mixed lubrication. Here, some asperities are in contact, not all. So the contact between the asperities is reduced to some extent. Load is supported by both. It is now supported by asperities as well as the film thickness of the, or film of the lubricant, liquid lubricant. So although not a true mode of lubrication, it is basically it is a transition. So it's not a true mode of lubrication in the sense of hydrodynamic or boundary mixed lubrication occurs. It occurs more frequently than it is realized. So mixed lubrication is a transitional mode of lubrication between hydrodynamic and boundary lubrication. So mixed lubrication is characterized by the likelihood of intermittent surface contact, because as I said, the load is not totally shared by the asperities, but it is shared also with lubricant film. So there are very less chance of the direct contact, but still the contacts are there. I mean, the asperities contacts are there. So to avoid this also, we are required to look into this issue, and EP additives and TVS additive property should be there in the lubricant to tackle or to handle this situation. And this is the most ideal situation, the third zone, hydrodynamic lubrication, because here negligibly asperities are in contact. The load supported mainly by the hydrodynamic pressure. That means the total load is supported by the hydrodynamic pressure of the liquid, and the film is taking care of that. So this is the reason why we call it full fluid film lubrication is the hydrodynamic lubrication. The oil adheres to the additives of the oil actually adheres to the moving parts and is drawn into the areas between the rotating surfaces where it forms a pressure or hydrodynamic wedge. So you will find in journal bearings, when shaft is rotating in a bush, at the point of contact, or you can say where the film is wedged into the space, and that wedge is called hydrodynamic wedge. So in hydrodynamic lubrication, this is the wedge where high pressure is developed in the fluid, and that takes care of the load on the pin. So a less common form of full fluid lubrication is hydrostatic lubrication. It's very less common. But machine parts which we are using in general, particularly the all camshaft bushings and crankshaft and crankshaft bearings. There we need to have a very good, lubricant so as to work properly, and the lubricating system should work properly so as to maintain the hydrodynamic lubrication in the that lubrication part. So as I said, these are the three very important zone to understand lubrication. Or I'll repeat that again from the Tribo curve. You can see from this Tribo curve, when boundary lubrication is there are a lot of asperities in contact. You can see that there are very few yellow lines between the two metal surfaces in interacting. But in mixer, you will find the asperities has reduced to very less number. So asperity interaction is very less, and in hydrodynamic there is almost zero asperity interaction. So it is the film which is squeezed between the space and causing to develop the pressure, and that pressure takes care of the load on the two components transmitting the power. So this is the curve which is very essential to understand properly the lubrication. And if these three zones are understood, and we are keeping some property in the lubricant to tackle the boundary lubrication, then there are very few chances of failure of the components. Now coming to the lubricant, you must be knowing lubricant is derived from the two very important things. One is called base stock, other one is called additives. When we say base stock is either a mineral oil derived material oil, or the other one is synthetic oil. So accordingly we name the lubricant as a mineral oil lubricant or synthetic lubricant. Mineral oil, when we say mineral oil, the oil is taken from different part of the country, part of the globe. So the nature of the oil is also different. It may be paraffinic, it may be naphthenic, it may be aromatic. So if it is, even if it is paraffinic, there may be the paraffinic chain is not normal chain. It may be a branched chain. So depending upon the type of base stock we have, or the source of mineral oil we have, its a basic property will be derived from that particular base stock. So base stock, basically, when we talk about base stock, these base stocks are not having all the required lubrication property. So in order to have all the required lubrication property to function that lubricant in the lubrication circuit, we need to put some additives, and that additives help us to maintain the certain required lubricants property to perform or to function as it for which it is designed. So I'll just go for the base stock. And the base stock, it is characterized as in 5 groups. We call it group 1 base stock, group 2, group 3, group 4, and group 5. From here, this slide, you can see group 4 is basically a synthetic base stock, polyalkyl olefins. And then rest of 3, group 1, group 2, and group 3. All these 3 are actually mineral oil based, where you can see the solvents percentage in grade 1 or group 1 is less than 90%, and it has sulfur content is more than 0.03%, and viscosity index is 80 to 120. Whereas in grade 2, you can say it is more than 90%, then more than still more than 0.03%. Sorry, it has to be less than 0.03%, and viscosity index is 80 to 120%. 120. GR3 is more than 90% solvates, and the sulfur content is less than. It's not. It's actually wrongly typed. So it is less than 0.03, and the viscosity index is expected more than 120. So base stock has a very, very important property when we are designing a lubricant. And just like base stock, we have a very good role of additives in the base stock. But before going into the different types of additives, I'll tell you something which is very, very essential for you all, particularly mechanical engineers, which are, who are there in the session. Uh, when I say the solvents, particularly, you go back. Let us go back to the previous slides. This is base stock. So when it is less than 90%, that means when we are using some additives, the solvation of that additives is slightly less than the 2 and 3. So that is important from different point of view. And when we talk about the base stock, actually we are looking for different property of the base stock, and those properties are viscosity index, pour point, then fire point in some cases, solvency, oxidation stability is also very important, and then toxicity, because in no case the base stock should be toxic in nature. And we are talking about green tribology. So if this is toxic, base stock itself is toxic, then after the uses of this lubricant, when it is discarded from the machine, disposal will become a big problem for us. So toxicity should not be there, and more important is the base stock should not be reacting to the system. That means the seal and all those things. So it should be very, very compatible also. So ideally, the solvency increases from grade 3 to grade 1, but oxidation stability of a base stock, I'm talking about base stock, oxidation stability is high for grade 3, less 2, and further, it is from 3 to 1, it is increasing. So oxidation stability is for base stock, it is high for grade 1 or group 1. But if we put some additive, the oxidation stability changes in the reverse way. That means oxidation stability is the highest for the group 3, slightly moderate group 2, and the lowest for the group 1. So this is very, very important. And viscosity, the ability that is also increased by putting some viscosity index amplifier, modifiers we call it. So many things are added. So let us talk about the additives. These are the additives which are very, very essential for the lubricant, which we are using in different machineries. Maybe it's an engine, or maybe transmission or gearbox, maybe in hydraulic system. So let us see this the additives. I have enumerated few of them. One is antioxidant or oxidation inhibition. You see, this is the additive which is most essential, because most of the mineral oils are not having the thermal stability. So in the process, when we are using the lubricant in the machine, what happens? There are a lot of heat generation, heat ingress, which causes the oxidation. And it is that lubricant is moving in the atmosphere of metals, and there are metal ions also. So that causes the rapid oxidation of the lubricant or base stock, or you can say base stock or lubricants. So if the oxidation is not inhibited, what will happen? The mineral oil are basically paraffinic or naphthenic, as I said. So what will happen? That oil starts oxidizing, getting converted, alkane will getting converted into gradually into the oxides, the alcohol, then acids. And once the acid formation is there will be a lot of esterification, there will be a lot of resin formation, there will be lacquer, varnish, and so on and so forth. So ultimately, the life of the lubricant gets reduced when the oxidation is taking place in the system. So the oil should have capability to avoid this oxidation, and for that we are putting some oxidation inhibitors as an additive. Friction modifier, as I said, friction modifier is nothing but it is the anti-friction additive. So we are reducing the friction with putting by way of putting this friction friction modifier. So the first antioxidant additive I'm talking about, that basically that are as an additive, if we talk about, it's a metal organophosphates in general, or it's a amine, or maybe organic phosphates. So organometallic, the phosphates or organometallics compounds are basically used for this particular property as working as an oxidation inhibitor. So when we are using this base stock as a paraffin or naphthalene, so from paraffin to naphthalene or unsaturated, what happens? The oxidation of the paraffin is most resistant, whereas for other base stocks, it is least resistant. So to make it more resistant of oxidation, we are putting these additives. So those additives are in general organometallic compounds. So this is one friction modifier. As I said, this is friction is modified by blending oil, which is we call is the compound oil. So we are putting a base stock plus a fatty acid or fatty acid content oil, which are blended together, and then the friction is modified. When I'm talking about friction here, I'm the friction or viscosity. If you consider the viscosity, you see the viscosity in general for the oils, we are measuring two viscosities. One is called viscosity at 40 degrees Celsius, another is viscosity at 100 degrees Celsius. Or if you go by the specification, you will find SI number, Society of Automotive Engineers. They designate the number, and those numbers are two numbers. One is called winter number, and another one is called summer number. So these days, the machines are using the lubricants which are having, both the properties, winter properties as well as summer properties. So if the oil is of, such two properties, we call it multigrade oils. Now, for example, 5W15 or 20W40 or 15W40, these are very common oil, even 0W15, 0W10. So if W and is also there in the designation of oil grade, so we call it, it's a multigrade oil. So there we are actually increasing the viscosity. And when we look into the viscosity, there are two viscosities. One is absolute viscosity, other is kinematic viscosity. So whenever we are analyzing the oil for its viscosity valuation or viscosity degradation measurement, we always look for absolute viscosity. But for the fresh oil, we always look for the dynamic viscosity. So this is very, very important, keeping in mind that for all fresh oils, we are measuring two viscosities, one at 40 degrees Celsius, other is 100 degrees Celsius, and then we go for estimation of the viscosity index. So that is there. Viscosity index improver is there. We put some viscosity index improver in the oil as an additive, and those are nothing but long chain molecules, polymer, that helps to reduce the effect on the viscosity of the lube oil under the variation of temperature. So in general, you will find the olefin compounds are used as a this VI improver. Another is very, very important, as I said, in almost all machineries, power transmission components, whether it is a gear, automatic gear, or automatic transmission, or maybe engine, this extreme pressure additives are very, very important. So there are two terms, anti-wear additives and then extreme pressure. When we talk about anti-wear additives, it's nothing but either a very common one is, you must be knowing it, that is called TCP. TCP is tripara crucial phosphates, and another one is called ZDDP, which is zinc dialkyl dithiaphosphate. This is very common. ZDDP is very common as an additive, anti-wear additive, or you call the additives used in the lubricant for taking care of boundary lubrication situations. So under the high pressure and temperature, this makes the sacrificial film on the surface of the asperities, and it is sheared off during the extreme condition. So it takes care of interaction of the asperities during the boundary condition. So anti-wear additives is very important. Extreme pressure additive is equally very important. As I said, whenever there is a extreme pressure, what will happen? Because of the line pressure, point contact or line contact, there will be extreme pressure, and during that extreme pressure, the asperities gets lot of heat ingress, causing the variation in microstructure as well as microhardness. So these additives are what they are doing. They are actually reacting with the metal surface and forming a chemical bond there, and they are actually not allowing these asperities to get deformed or to get dislodged from the surface. So this is actually helping to reduce the rate of wear in the extreme pressure conditions. The oils or lubricant are also required to have anti-foaming additives. This is important when there are a lot of heat. Not only the heat ingress, the contaminant as water or air is trapped into the lubrication circuit. So in those circuits, the foam will start forming, and the oil should have capability to reduce the foaming ability. So that additive is called anti-foaming additive. Then this is another very important detergency and dispersency, because once the contaminants are there in the lubricating oil, lot of debris is getting created during the process. So the oil should clean that component, and that property is detergency property. And once the debris is removed from the component, it should be dispersed. It should not be allowed to coagulate and make the resin or varnish. So that should be dispersant in the whole bulk of the oil. Another, when there is a chemical reaction between the lubricant and the body, so there will be corrosion. So to avoid this, we put some corrosion inhibitor in the oil as an additive. Likewise, the demulsifier is also there in the additive. So these are the very, very common additives which we are using in a lot of lubricants. Now, I'm going to show you some of the cases which I faced during my tenure as a general manager in Coal India. So I'll give you the glimpses of some cases where we were handling these issues. This is a hydraulic excavator, which is very common in open cast mining. This is called face shovel. Another is a backhoe shovel. It is also the same excavating equipment, but it is the cutting profile or cutting envelope is different. It is taking from the lower bench to the upper bench, and the cutting profile is different. So this is a backhoe shovel. And here I am giving you a list of lubricating valves which are being used in CCL. It is very common in other subsidiary of CIL also, because the equipment is more or less same, or configuration more or less same. Only thing is the capacity will be different. So see this engine oils which we are using here is a multigrade engine oil, and it is 15W40 type CF4. And you see these are the application where we are using on BML dump dozers. It is a 320 HP dozer, then 410 HP dozer, the 60-ton dump trucks, the motor graders, the excavators. So this is very common, a multigrade oil, which are being used in the HMMs. And you see the specification or standard performance level required is API CF4 grade. So this is a standard. When we are designing any lubricant, that lubricant has to go for different various tests. And one of the important tests is the the OEM performance level test. So this is the OEM performance level test, which is indicated here. And you see the consumption. I am giving this table only to just expose you the amount of oil we are using in Coal India, different grade of oil in different subsidiary of the Coal India. But I am giving only the data related to CCL only. So it is 475 kiloliters, 750 kiloliters. This is multigrade engine oil again for another equipment. So these are the different engine oils we are using in the different HEMMs. Then we have hydraulic oils. Hydraulic oil is SAE 10 or Ultra 10, or maybe ISO VG 46. ISO VG 46 is very, very important. ISO VG 68 is also there. VG stands for viscosity grade. Viscosity grade 68 is because viscosity grade 46, and in some cases 33 also. So the highest viscosity grade we are using is VG 100. That is there in the L&T make equipment and the L&T excavators we are using there. So see this 900 kiloliters, 600 kiloliters. So altogether 2200 is 2200 kiloliters. So almost you can imagine the amount of oil we are using, hydraulic oil using in the Coal India. I mean CCL I'm talking about. This is very another important application of oil, lubricating oil. It is transmission oil basically. And transmission oil is a C4 SA3 30 grade. This SA30 or Ultra 30 we can call it, or C4 SA30, or there is another grade we call Komatsu TO30 or Sparex S4 CX30. So all are basically SAE30. Viscosity grade is same, but only the additives are different to suit the application of their manufacturer. And here you can see the 1800 kiloliter transmission oils we are using per year in CCL. And the gear oils again are different, but mainly it is SAE90 or SAE40, 140. On VG grade wise, it is starting from 220 VG grade up to 680 VG grade. So these are very high viscosity grade lubricating oils we are using in gearboxes of different HEMMs deployed in CCL. Then after gear oil, the greases and OGLs. Now, important part here is OGL. OGL is open gear lubricant, and open gear lubricant usually you will find in shovels and wherever there is a girth gear or I mean swing gear. There we always use these OGLs. So a OGL, either it is a bituminous based OGL or maybe synthetic oil based OGL. But now gradually we are switching from bitumen based to the synthetic oil base. These are the oils, as I said earlier. Now to take up the issues related to lubrication, or lubrication challenges in the industry. Most of the maintenance of the hydraulic system of hydraulic excavator can be amicably handled by the way of practicing well-planned condition-based maintenance. See, this very, very important part for all mechanical engineers these days. The equipment and the quality of equipment, quality of maintenance required these days are much more higher than what we need earlier. So now the maintenance hierarchy itself has changed from you can say the reactive maintenance to predictive maintenance, and now finally to the condition-based maintenance. See, condition-based maintenance has a two-prong. One is called predictive, other one is called proactive and predictive. So when we are doing a proactive maintenance, what we do oil analysis, debris analysis, thermography, FTR and ICP spectroscopy. And based on these analysis, whatever the data we are getting during analysis for different samples, we train the variation also. And if there is an indication of deterioration, immediately we start attacking for predictive activity. So in this way, by way of going this condition-based maintenance, what is happening? We are saving a lot of time, and more important is the the catastrophic failure has been reduced to almost to very negligible value. So if we are practicing religiously this condition-based maintenance, if I'm not talking about the higher level of maintenance, because other hierarchy of the maintenance is reliable centered maintenance, RCM, and another, there is a TCP. So total productive maintenance, TPM. So we are not talking about TPM, we are not talking about RCM, but at least in coal India, in a bigger, particularly bigger mines where the bigger capacity equipments are deployed, there we are religiously working for condition-based maintenance. So this is not only time-based maintenance, we are proactively going before time, scheduled time, taking the sample of the oil and also debris, and we are doing this oil analysis, debris analysis. So through these analysis, mainly we are coming to know about the health of the oil, and accordingly we are taking care of. So this helps two ways. One, if the health is not deteriorated, we can extend the life. So we are just going beyond the prescribed life. So in this way, the MTBF is increased and internability is increased. And second, we are saving a lot of foreign exchange. So this is important because we are enhancing the life or the you can say drain period. So by way of enhancing the drain period, we are reducing the consumption and reducing the foreign exchange, and so many. So the cost of maintenance is also getting reduced by practicing this condition-based maintenance. These are the standards we are following in Coal India for oil analysis of lubricant, particularly for kinematic viscosity, viscosity index, and total base number. Total base number is very, very important because the deterioration of the additives is estimated through the evaluation of total base number. Usually the total base number is more than 12, but if it is the additives are degraded over the uses, then it reduces to 50%, and once it is reduced to 50%, we need to change the oil itself. But if it is below 50%, we can use the same oil with the top up. So we are not replenishing complete oil circuit or tank, rather we are just topping it up. And there are the standard for sampling the oil. And then very important part is the cleanliness level is maintained. So cleanliness level is maintained not only by reducing the contaminating elements, but also we are putting the right kind of filters in the system, right position of the filter, and also the the medium of the filter is also important. So we are taking care of all the three sizes of the contaminant particle. We call it R4, R6, and R14, and then we see what is the prescribed cleanliness level by the manufacturer, and we are trying to stick with the this cleanliness level of the manufacturer so as to enhance the life of the pump and all the different hydraulic components. So this is important to know you all. We had one case study there for changing the viscosity index. So we worked for a change of the oil, and this viscosity versus temperature was plotted, and we with this exercise, with this case study, it is established that VI, if it is VI is improved, that impacts the volumetric efficiency and in turn overall efficiency. So it is the volumetric efficiency. It's not only the hydraulic pump efficiency, but volumetric efficiency also helps to maximize the pump overall pump efficiency. So this work was done during my tenure in Coal India, and then this was the inference drawn, and you'll surprised to know from this inference that only by changing that only one oil I'm talking about, it is Servovis E46, that has changed so many things, and these are the benefits. You can see the benefits. Benefits are the fuel, specific fuel efficiency has gone to increased by 8.5%. Then the hydraulic oil, the time needed to complete the dumper's loading trip, that has found to be lower by 7%. Because of the better pumpability and better overall efficiency. And with this, the fuel consumption, you see the last line, the diesel consumption by excavator for each dumper loaded reduced by 6%. You can imagine if hundreds of thousands of kiloliters we are using in Coal India. if the 6% reduction is there in diesel, you can imagine the cost saving. So this is very, very important. There are many cost case studies which are required to be discussed, but because of the paucity of the time, I'm not going into the detail. Now coming to the application of the tribology, and this this is very important for all of us, because tribology is applied to the most common rolling and sliding components, which are bearing, gears, cams, brakes, and seals. These common elements are used in the variety of machines. I shown you a lot of the machines there. So this early focus on enhancing the operating and extending the life of the industrial machineries has evolved into the other application where it has made a major impact on the variety of applications. Now I'll give you in brief what are the different applications. It's a classical tribology, the biotribology, the green tribology, the geotribology, nanotribology, tribotronics, very, very important. And the recent budding and flourishing tribology is tribotronics. So this is tribotonics in the industry 4, where we are talking about a lot of talking about the artificial intelligence, IoT, then we are talking about the data science, and then neuron network, all those things. So here we are capturing the data related to tribology through the different electronics activity, and then we are suitably designing the most critical pairs or joints, we can say. So space tribology is also one of the area where a lot of things are being used. This is we are discussing here. So this green tribology, when we are talking about the green tribology, it is also bringing a lot of challenges. See, whenever we are talking about the green tribology, energy saving is one, and that energy saving by implementing tribological technology. So when we are talking about tribological technology for energy saving, they also requires a lot of new technology to have better tribological components. So this is one area where we are talking about. And then as I said, a lot of additives we are using in the lubricant. So ideally, the lubricant should not use toxic substance in those as an additives. But the most toxic substance which we are using there is sulfates and phosphate, because anti-wear additives, as I said, anti-wear additive is ZDDP. ZDDP is zinc dialkyl dithiphosphate. So the sulfate is also there, thio is there, and phosphate is there. So we need to work on this area, how to reduce the uses of such toxic substance. So if you reduce the toxic substance while researching the new material, this will help us to reduce and enhance the green tribology. Likewise, we have it should be little or no use of mineral oil. These days we are talking about a lot of things. We are talking about the aqueous based lubricants or solid lubricants. So in place of liquid lubricant, we are trying to go for the solid lubricant, such as biofilm coating and biofilms and nanomaterials. There are a lot of nano coatings also. So those can be helpful to bring the green tribology. And these are the areas where we can see there is another very important area, EV. EV, we call it e-mobility or electric vehicles. These are very common, and hopefully within next 5 to 10 years, we will have a lot of electric vehicles on the road. And if we are talking about the electric vehicles on the road, tribological challenges are there. What are the tribological challenges in the electric vehicles? The first one is the battery material. You see, till date, in the batteries of the vehicles, we are using the lead acid battery. And lead is, as I said, it is a toxic material. So we have to reduce it, and these electric vehicles are using the lithium-ion battery, LIB. So we need to work on the LIB and how to increase the efficiency and the cost effectiveness of this material. Then high speed bearings. You know, the e-vehicles, where if we're talking about the turbochargers, I mean the engines are turbocharged engines, and you know the turbocharger speed itself is very, very high. It's in some of our vehicles, these turbochargers are going up to even more than a lakhs RPM. So if such is the high RPM of the I mean the rotors of the top turbocharger, what will happen? It requires the high speed bearings also. So we need to design such bearings which can operate safely and smoothly, without using much of energy. I mean energy wastage, and cutting down the energy waste, and reducing the the losses. So high temperature is one area. High load and low speed gears are very common these days. You must be knowing. Even in I mean this wind energy, or there are a lot of bearings we are using in this wind turbine. And those bearings, if you look into those bearings are required to be looked from the tribological angle. And if we redesign that the area, we can have a more efficient the wind turbines, and because a lot of bearings are being used in the wind wind energy. So with this I conclude my this green tribology topic, and I thank from my core of the heart to the entire management of BCET Durgapur, the entire organizing committee of for this STTP, mechanical engineering department of BCET, and all faculty members, students present here in my this session. And a special thanks to Sandeep Kumar sir, HOD of Mechanical Engineering, Bengal College of Engineering and Technology. Thank you so much. Thank you all. Now it's open to you all. You can ask your queries, your questions. Thank you, sir.
Okay. Audience, please, have you any questions? Then you ask and sir will solve the questions. From audience sides, have you any questions? Okay.
Vinay sir, you are not audible.
Vinay sir.
You are not audible, Vinay sir.
Vinay sir.
बोलिए सर.
आवाज आपका. हेलो.
Hello.
Yeah, audible. Vinay sir.
Thank you, sir. Thank you, Professor Vishnu. We are very, very delighted upon your short lecture. Still, you have a very bad health.
Vinay sir, your sound is.
Sir, you are not audible, sir.
Vinay sir.
But it is saying that in my mobile.
Vinay sir, you are not audible.
Now audible, sir. Hello.
Vinay sir, I think some problem in your mic.
My network not working here. Hello.
Yeah.
Hello. Howdy, sir. Can you hear me? Hello.
Yeah. But some echo, I think.
Sir, network is here.
Not me.
Thank you.
I think, sir, from audience side, no any questions. Then, Vinay sir. Hello.
Hello, बोलिए sir.
Then you conclude the session. I think no any question from the audience side.
ठीक है sir. So thank you, sir, Professor Vishwakarma. It is a very absorbing lecture on tribology and also from green tribology. We now come to know what is the huge application of green tribology all over the world together, all over the mechanical, electrical, electronics. So very, very thankful, sir. We expect to know more from you, sir. Thank you very much.
And I would also thank you, sir, Dr. S.C. Verma, sir, and so many thanks in the behalf of the organizing committee and the audience side. And I thank you, Dr. S.C. Viskarma, sir, for your valuable information you share with us and in this presentation. And thank you, sir. Again, once, thank you, sir.
Thank you, Ravani sir. Thank you, Vinay sir. And thank you, Sandeep sir. If Sandeep sir is there, can you hear me, Sandeep sir?
I think, sir.
I think he is not there.
Not there, sir.
Maybe he is engaged with some other activities. So with this, I'm again thanking you all the entire organizer, Professor Binay Sarkar sir, and he was, I think, in the previous session I heard he is associated with some underground mining machinery also. So if something is required to be helped by me, sir, I am ready to help you all. I am very much privileged and thank you all to the entire organization that they are, Bengal College of Engineering and Technology, all staff members and all students, dear students. If you require any help on this area, I can give you the n number of inputs which are there from the industry. Because of paucity of time, I could not take you to the different case studies. I could have taken n number of case studies because I have handled so many cases during my tenure. So all the students who are looking into this area, is domain, this is a very, very important domain. This will be a value addition domain. So once you are aware of this particular green tribology or even the component of the tribology, you will be immensely, getting advantage of it. So thank you all, and my services will always be ready for you all.
Thank you, sir.
With the folded hands, I thank you all. Thank you.
Thank you. Well.
Now I am wrapping up my session, sir.
Yeah.
Thank you all. Thank you, Ravani sir. Thank you, Vinay sir.
Thank you, sir. Thank you, sir. Dear participants, next session will started after some time. I think 5 to 10 minutes after the next session will start. Okay.
Okay.
Okay. Dear participants, next session will start, I think, in next 5 minutes. Please wait.
Okay, sir.
Okay. Hello. Hello, dear participants. Our resource persons, Dr. Prabhu Deva sir, is also joined with us within 5 minutes. So please wait. Became sir. Hello.
Yes, sir.
Yeah. Our resource person, Dr. Prabhu Deva sir, is also with us. Good morning, sir.
Good morning, sir.
Good morning, sir, and welcome in our short-term training program, sir. 5-day short-term training program. And I invite Mr. BKM sir to introduce Mr. Dr. Prabhudeva sir and in brief introduction, sir. Please, BKM sir.
Okay. Thank you, sir. First of all, I would like to say good morning, sir, Dr. Prabhudev MS sir, and my dear participant. On the behalf of Mechanical Engineering Department of BCET, myself, Professor Birendra Kumar Mahato, welcome to all of you for the last day of this short-term training program on trending trends in advanced material, function, manufacturing, and design. So, first of all, Dr. Prabhudeva sir, good afternoon, good morning, sir. Dr. Prabhudev MS sir completed BTech in Mechanical Engineering in the 1996 from PDA College of Engineering, Kalburgi, Gulbarga University and Kalburgi with first class with distinctions. He also obtained Master of Engineering in Manufacturing Science and Engineering in the year 1999 with first class with distinctions from Bangalore University. He also Doctor of Philosophy from Visvesvaraya Technical University in Mechanical Engineering Science in August 2011 under the guidance of Dr. S.A. Kori, Vice Chancellor of Central University, Andhra Pradesh. He is the first faculty in the Kalyan, Karnataka region at Government Polytechnic level. And currently he is associated with President of Karnataka Janana Vijnana Samiti, Kalburgi district, founder president of Green Club Kalburgi, founder president of Green Health Club Kalyan, Karnataka Kalburgi. He is also elected executive committee member and member of subcommittee of the Institution of Engineers India Kalburgi Local Center Kalburgi for 2016 to 18 and 18 to 21. He has also elected 3rd times in a row. And apart from this, he is a committed teacher. He served as lecturer, senior grade lecturer, and selection grade lecturer since 1998 at Government Polytechnic, Kalburgi. He has also more than 21 years teaching experience. And he has also worked as principal in charge and HOD of Government Polytechnic, Kalgi, and also initiated various academic reforms and development activities of the institute to bring the quality and mainly to improve the quality-oriented result. He has also worked as chairman and member of Administrative Academic Committee of Government Polytechnic Institute. He is also advisor and visiting faculty to Hyderabad Karnataka Center for Advanced Learning and Welfare Society, NGO, Gulbarga. He is an active member of professional bodies at international and national level like life member of Indian Society for Technical Education, New Delhi. Also, fellow and life member of Institution of Engineers India and life member of Tribology Society of India, New Delhi, and donor and life member of Karnataka Rajya Vijnana Paristu, member Karnataka Janana Vijnana Samiti Kalburgi, life member Kannada Sahitya Karnataka, and also life member for Society for Failure Analysis Karnataka section, member government officers Club Kalburgi. And after that, he has published so many research papers, and that means 10 reputed international journal and 2 national conferences, 17 international conference. He is also organizer and coordinator of workshop and short-term training program for faculty of polytechnic and engineering colleges. He is organizer and coordinator for students seminar and workshop. He conducted and chaired technical session at international conference at Vellore Institute of Technology, Vellore, KJ College of Engineering, Pune, Trinity Engineering College, Pune, and GH Rai Soni College of Engineering, Pune. He is also reviewer of many international journal and conference paper and also reviewer of international journals like Tribology in Industry and the Journal Tribology Malaysia, Industrial Lubrication and Tribology, and many international conference papers. So now I request to Dr. Prabhudev MS Sir, to continue today's lecture on green tribology and sustainability in industry. Good morning, sir.
Good morning, Prabhudevas. Good morning, Mahadev sir.
Good morning, sir.
This is Vishwakarma, SC Vishwakarma, ex-general manager. I was having session just before your session. So it is continuation of the green tribology itself. You're not audible, sir. Please unmute your mic.
Oh, good morning, sir. Good morning once again.
Good morning.
Good morning to all. Thank you for Subrata Ghosh for introducing me. Vishwakarma sir, what are all the things you covered, sir? Actually, I would like to know so that I can skip those things and cover the other things so
Sir,
that
I dwelled
everything
on
is not repeated once again.
Okay. I dwelled on the green tribology, sir, the recent work and what is green tribology as a concept, and then basics of tribology, then lubricant design, and then the additives which are being used in additives in a lubricant, which are affecting the tribology, green impact on the environment, so that the green tribology is protected. So we have to work on those areas, sir, as a substitute for the ZDP and all those organometallic additives, sir. So that I have covered. I have also exposed some of the application of the green tribology also. So I think your session will be, helping to the researchers also, sir, because you are going to dwell on the tests. I have not covered the test part, sir.
Yes. Surely. I will go through that some basic fundamentals with Tribo testing part of tribology, sir.
Right. I have intentionally.
Happy to meet you online, sir. Once again, namaste. And
yes, sir, namaste, sir. I intentionally left that part for you only, sir, because Tribo testing is a separate domain altogether. So
yes. My intention was also to cover green tribology with more emphasis on sustainability related to industry. But anyhow, much part of the things have been covered by you. So I will cover the remaining things. Thank you, sir. Thank you once again.
Thank you, sir. Thank you. Namaste.
Just let me share my PPTs.
Yes, sir.
Ghosh, sir, is it visible?
Yes, sir.
Yes, sir. It is visible.
It is in show mode or it is in?
No, sir. Small.
Sir,
please.
Sir.
No, it is in show mode, full screen mode.
No, sir.
No, sir.
1 second. Is this? So I will try to share entire screen.
Yeah.
Sir, if you would press F5, it would go to the slideshow mode.
Oh, 1 second. I'm sharing window.
No, sir.
Entire screen.
Yes, sir.
Yeah.
Yes, sir.
F5 I pressed. Is it in full screen mode?
No, sir.
No, sir.
It is not.
Clipboard is
in
coming,
mode.
so you can just eliminate the clipboard.
Sir, function plus F5.
No, I pressed F5.
Function key
Yeah.
is in your
Function key
control
will be
button.
F5. Okay. Let me share the entire screen. Let us see whether I can. Now, sir.
At present, not sharing your screen, sir. Eh,
Now, is it in full screen?
Yeah. Yes, sir.
Yes, sir.
Now it's
it
okay,
is.
sir.
Fine. I shared a full entire screen now.
Okay, sir. Okay, sir. Now, sir, you may continue, sir.
Yes. Okay. Good afternoon, dear all delegates, participants,
Good afternoon, sir.
Dr. Vishwakarma sir, and all the coordinators and all the faculty members who are present online. So actually, I thought before the training program, being one of the coordinator for this STTP, I thought to cover the green tribology and sustainability in industry. But keeping in mind the things already covered by our Dr. Vishwakarma sir, so I will cover what do you mean by tribology, some fundamentals with the latest developments, offshoots of tribology with more emphasis on the tribology testing or tribo testing, what we say. So I am Dr. Prabhudev, MS, selection grade lecturer working in the Department of Mechanical Engineering, Government Polytechnic Kalgi. So as this STTP 5 days STTP trends in advanced materials manufacturing design, which is organized by Bengal College of Engineering and Technology, Durgapur, West Bengal, in association with Karnataka Gnana Vijnana Samiti, Kalburgi district, and Institution of Engineers India, local center Durgapur and Kalburgi, Karnataka. So I am very happy to be part of this 5 days workshop or STTP with many stalwarts given talks on different topics on materials manufacturing and design related things. So what are the things? I mean, the tribology basically it is the least given importance in our day-to-day life as well as in the industry. Not much importance is given to this tribology field. So actually, I thought to cover all these things in this today's 1.5 or 1 hour session. Introduction to tribology, history of tribology applications, why we need to apply tribology, benefits, some types of views, mechanisms, offshoots of tribology, green tribology and sustainability. But now I thought to shift it to the tribology testing part. So as you know, already Vishwakarma sir has covered the tribology. Our great civil engineer from Karnataka, Sir M. Vishweshwaraya, who comes from Mokshagundam, Chikkaballapur district, he quoted, industrialize or perish. That means development is must, but environment is first. So energy is indication of economic development of a country. So energy is life. Conservation is instinct of life. As you can see, energy is used in manufacturing industry, the power industry, the automotive industry. So there are a lot of problems we are facing, environmental problems, pollution, global warming, acid rain, etc. So the current trend is, one is energy conservation. That is, whenever there is a motion, there involves a friction, there involves a power loss. So we need to go for lubrication to reduce this friction, power loss, heat and etc. take example of the bearings. So we need to, the second trend is the material conservation, that is wear, and lastly the natural conservation, by which we can achieve the sustainable development goals as given by the UNESCO. So the most common forms of failures in day-to-day life in industry mostly are corrosion, fatigue, and wear. Wear is the child of tribology. So if you look at this left-hand side image, the shoes what we wear, the top shows is you can see smoothened because of its more use. The bottom shoes you can see observe. So we can say the top one shoes is worn more. And even if you can see the two tires, left hand side and right hand side, you can see the smooth surface on the left hand side and the natural surface or the tread, natural tread of the tire. You can see we can say this left hand side tire is more worn due to material loss because of its usage. So these are the photographs of the brake shoes of my Sia's Maruti Suzuki car taken after running for a 49,000 kilometer. Actually, you can see the 4 brake shoes. These are more worn out as compared to the bottom one. So Brown's first law of applied tribology says if it's running, it's wearing. That means anything which is in motion, so it loses some property. Say it loses its material property or material loss will be there, volume loss will be there. That's called wearing. It's wearing. If it's not running, it's probably worn. That means it is not further use. So tribology, I think the definition of this has already been covered. Tribo means rubbing, ology in study of. So the study of science of rubbing is called as tribology. Tribology is not a new field. It is as old as the human kind of civilization. It existed early in the history of Greek. And so it's a multidisciplinary subject involving the study of chemistry, physics, mechanical engineering, reliability, applied mathematics, solid mechanics, and material science. So tribology is the study of friction, wear, and lubrication. So if you look at the tribology tree, you can see it's multi-interdisciplinary in nature. At the bottom, you can see material science, you can see the fluid mechanics, you can see mechanics, chemistry, physics, mathematics, mechanical engineering, measurements, and many other things. It's an interdisciplinary nature. So this could be your area, this branch. The right hand side bottom branch could be your area. Whatever these 5 days workshop focuses on materials, manufacturing, and design. So tribology affects all these things. So whenever a product is to be designed, the tribology aspect is to be taken into consideration. When it is manufactured or the material selection is done, the tribology aspect also during the usage, the application part is taken into consideration. The tribological approaches are to be applied so as to increase the durability, reliability, the life of the component, and the maintenance, taking into consideration the maintenance part. The tribology plays a very important role as like the energy conservation. Tribology is one of the important source of energy conservation. Please switch off. Tribology is one of the important source of energy conservation. So if you look at this slide, you can see some simple day-to-day examples of tribology. Morning, after we get up, till night we sleep, go to bed, we can find very, very simple applications of this tribology involving wear, friction, and lubrication. When we brush our teeth with the help of the toothpaste using a brush, so there will be the tribology comes into play. So the toothpaste acts like a lubricant in between the surface of the brush and the teeth. So it cleans our teeth. So take example of shaving, the second sketch, shaving. So the shaving cream what we applied on our skin to remove the hairs present by using the razor blade. Okay, so this also involves the application of tribology. Walking is possible only because of the friction existing. So friction is both desirable and undesirable. The running and walking can only be possible because of this tribological application. So if you write with the help of a pen or a piece of pencil or with the help of a chalk on a board, that is also involves tribological applications. The eyeball blinking in your eyes, that is also because of this tribology. So the vehicles running on the roads, the tire coming in contact with the road that needs friction. So that is also a simple application of this tribology. And even the rubber eraser what we use to remove the things written by the pencil involves the tribological applications. Many things like even the human body in which many parts are moving when we work, when we walk, when we sit, when we move our body in different directions to do some kind of work involves the hip and knee joint, wherein which a lot of movement is involved with applications of load in different directions, also involves the tribological studies and applications. If you look at these images, so these images I have taken at the Bhogalingeshwara temple near the Chikkapallapura districts where Sir M. Vishweshwaraya was born. Last year I have been invited as a keynote speaker for the 10 days research methodology workshop. During that time I have visited this temple and I took the images of these two goddesses. If you look at the statue at the left hand side, due to the withering action, maybe due to the sunlight, the rain and all the things, so you can see the surface of the statue, you can see how it is like. And if you look at the statue on the right hand side, which is placed inside the temple, you can see very smooth surface. This also involves the application of tribology. Fine. Then some of the industrial applications of tribology, you can see the single component assemblies, manufacturing, and some products like the journal bearings, the piston moving inside the cylinder, the machining operations, so the radial ball bearing, the cam and follower mechanism, the gear drives, etc. These are all the simple examples and importance of tribology. So this, if you look at this sketch, it shows the importance of tribology in various applications like in brakes, in the vehicles, what we use, and clutches and the tires, which requires minimum wear with maximum friction. So they should be wear resistant material. As like the eraser or the rubber, what we use for removing the things written by the pencil with the help of pencil. So that requires the increased adhesion. There should be a maximum wear and maximum friction. Friction should be more, as like wear will be more, because the written things are removed by that rubber. Similarly, the pencil, it requires a minimum friction because there should not be any noise or sound while we write. It should write smoothly, and maximum wear so that the material is being transferred from the pencil onto the piece of paper. So similarly, we need to have minimum friction and minimum wear in case of bearings, gears, cams, slideways, and many mechanical devices which are having motion. So basically what we can say, wherever there is a motion, there is a friction, there is a whenever there are two bodies involved having contact with each other, having relative motion between them, that results in this tribological approaches, I mean the tribology. So for the wear or the friction to involve, wear means the loss of material because of the movement between the two materials. Okay, fine. So here I have shown, this slide shows the different applications of this tribology area in the bearings, in the gear drives, that is in machinery, in the production, like in the machining. If you study the theory of metal cutting, There you can come to know the different kinds of wears, flank wear, and other kinds of wears. Even in transportation, we can see the movement of the tires over the road surface, and even the medical technology that is called as biotribology, hip and knee joint, there also we can find the use of this tribology. So I will not go in detail regarding this tribology and all these the types of wear and other things. Sir has already covered. So this tribology, approximately 1/3 of all the device produced energy is lost through friction and wear. So it affects life, product life, reliability, safety, and the environment. So in the USA alone, the losses occurring due to friction and wear are over 200 billion. So breakdown maintenance costs over 3 times that of the plant maintenance. So this slide is very important for the young budding engineers who are attending this training STTP. The engineers coming out of the technical institute will be responsible for improving and maintaining the reliability of plants and their equipment. In industry, however, maximum emphasis is given to preventive and breakdown maintenance, and tribology is neglected. In the earlier itself, I told you, tribology is the field which is most neglected. Many people, even till they don't know what is meant by tribology, even though it is responsible for over 40% of the breakdowns all over the world. So inappropriate understanding on application of tribology is one of the major reasons of failures in industry, resulting in loss, economic loss, money, and even in maintenance cost. So why we need to study tribological knowledge is important because it reduces friction. So it reduces earlier in the earlier session, sir has covered it. He has shown that it reduces energy consumption because of the lower friction. Less energy can be dissipated as heat, and thus energy consumption will be reduced, and we can do efficient lubrication also. Fine. And so a spear kept on a flat surface, you can see no surface ever produced is very perfectly smooth. If you observe the same spear kept on a flat surface under a microscope, you can see the asperities. So hardly you will get here and there contact. So those are called as crests or valleys or asperities. So you can see once again. So the types of wear in industry, the abrasive wear, there are different kinds of wear like abrasive, adhesive, erosion, fatigue, and chemical. So the abrasive wear dominates 50%. Other things are having lesser this thing. I will not cover these types of wear. Sir might have covered these things. So these are the practical examples of wear, abrasive wear, as you can see in the earth moving equipments, material handling tubes. So adhesive wear, you can see it, observe it in rubbing bearers, clutches, brakes. Fatigue wear in connected rod joints in IC engines. Particle erosion in pipeline carrying abrasives. Cavitation erosion in marine propellers, like that. Surface fatigue in roller bearing races and elements. So the recent developments or offshoots of tribology are nanotribology, disc or tape tribology, nuclear tribology, space tribology, automotive tribology, wind power tribology, mining tribology, marine aqua tribology, biotribology, and lastly green tribology, which has been covered by Vishwakarma sir in the last session. So human beings, as we get old, the elder people, usually they suffer from a kind of disease related to orthopedic related disease that is called as arthritis, which is a leading cause of disability among the elderly persons, age-old people. So if you take example of the Australia, in Australia alone itself, osteoarthritis affects more than 50% of the population over the age of 65, that is senior citizens, at a cost of over $25 billion per annum to the economy and health system. Despite its high cost to many societies across the world, there are no effective treatment for the disease or even symptom relief pain, with the exception of weight loss and joint replacement. So alternate solution is to replace the hip and knee joint with glass, steel, rubber, acrylic, and material combinations were used for hip joint replacement. But if you use these materials, the problems will be the artificial joint produced with these above materials should not only be biocompatible, it should be adjustable to human body, but it should also withstand the body stresses, loads, and it should have minimum wear. So the final solution, what they have found out is UHMWPE. So the extension of this material name is ultra high molecular weight polyethylene as a bearing surface. So that resulted that is nothing but it is the output of this tribological development with the replacement of hip and knee, which will reduce the pain. That means pain relief is provided with improved mobility. So you can see the hip and knee joint. So this is the upper bone, the lower bone. You can see this side, the unloaded regions. Okay, here where actually the contact occurs between the upper bone and the lower bone, hip and knee joint. So this part is called as a load bearing region. So as I told, tribology is everywhere. Tribology is life. Without tribology, we cannot imagine our life itself. Everything is dependent upon tribology. Tribology is heart of engineering. Without tribology, we cannot do anything. So here you can see the contact between the upper bone and the lower bone. So due to this continuous movement, with the movement or mobility of our body, so usually the synovial fluid is present. With the age-related problems, the synovial fluid will be lost. So that increases the contact between the bones, and that leads to wear, and those wear particles are entrapped between these two bones. That may also further lead to more complications. So people feel age-old people feel much pain in the hip and knee joint. So they may go for surgery, replacement of hip and knee joint. So knee implant is a very good example of a tribological application in human body. That is called as a biotribology. So what they have done is a knee joint is just like a hinge joint. It acts like a hinge joint. So by using some software, so they have made a stress analysis, and stress concentrations were find out, and wear of the implant is find out, and they manufactured the hip and knee joint by rapid prototyping and investment casting by using this material UHMWPE. So you can see this, it acts like a hinge joint. This is the fibula, the bottom bone, the femur, and the patella. So just like a hinge joint, again you can see femur, fibula, tibia, and the patella. So again more clearly you can see the metal femoral, this upper thigh bone, the metal femoral and tibia components are made up of cobalt, chromium, molybdenum, cobalt material, chrome, which has got a high specific strength, and a titanium 6 aluminum 4 vanadium. So the tibia insert and patella are made up of polyethylene. Here you can see the top one femur part, the bottom tibia part, and the the tibia, the middle one. So that reduce the pain and increase the mobility. So this is a very good application of biotribology. And nanotribology, which is the study of wear and friction at molecular level, like MEMS, microelectronic mechanical system. So tribology and sustainability. We need to see everything in terms of sustainable development or sustainability, okay, for the future generations or future society. So these are the challenges: population explosion, climate change, degradation of environment and natural resources, and sustainability. So the issues or the important role of tribology is development of new technology to keep alive and healthy, maintaining our standard of living to keep our biosphere intact. So the GHG, greenhouse gas emissions, are reduced. So friction is everything. As you know, life would be smooth, but life would be slippery if no friction. If friction is necessary, and somewhere it is not necessary. Higher the friction, lesser the happiness. So lesser the friction, more happy you are in life, but not between your shoes and floor, and not between the better half. Fine. So the married people can understand in a better way. So friction was not a new term; it was very old. So you can see the application of this tribology in the earlier history. In the statue was transported from one place to another place by using water, some kind of solvent like water. You can see a big statue weighing around more than 600-800 tons is moved by pouring some kind of liquid. The earliest tribology engineer can be seen over here. Okay, so these are the environmental effects which we have to take into care when we use the tribological applications in industry or anywhere else. So every product has to be sustainable, every process has to be sustainable. So the 6 key factors for achieving sustainable manufacturing, you concentrate on this. Optimize your current use of fossil fuels, the petrol and diesel. Eliminate the waste by using the terms reduce, reuse, recycle, recover, the 4 R's, and save the time. So energy wasted due to friction and wear in a automobile or in an engine can be, like example of, I have taken example of this graph. Fuel energy contains 100% energy. Out of this, 30% goes as exhaust, 20% for cooling, and remaining out of that 50% for mechanical work. Around 7.5% is taken as engine losses. From this, thermal losses for this much, and frictional losses around 33%, air drag 13.4%, and auxiliary 3.1%. So finally, this much will be the total energy loss. Only 34% of the energy is used for moving the vehicle as a power. Okay, 7 quarts of energy is wasted annually due to friction in passenger cars annually. So this is energy consumption annually. I am talking this because tribology is one of the potential source of energy savings. Okay, so with proper tribological approach, we can reduce the friction, we can reduce the heat, we can reduce the power loss, we can reduce the fuel consumption, we can reduce the energy loss. So with minimum maintenance costs. So green tribology already sir has covered. It is specifically related to maintaining an ecological balance of any potential environmental biological impacts of the interaction between various surfaces that can occur between materials. So green tribology, actually it involves 3 principles. Okay, considering the environment and human health effect. So one is biomimetics. Biomimetics means bio means living, imitating the living models. I mean the copying or duplicating the living organism, something like copying from some birds, copying from some mammals, animals, and elements in nature to solve some complex human-related problems. And self-lubricating materials and surfaces, biodegradable and environmental friendly lubricants, renewable and sustainable sources of energy. So the objectives of green tribology is low energy consumption, low discharge, GHG, greenhouse gas reduction, low environmental cost, and high quality of life. So I will not go in detail regarding this green tribology. So sustainability is nothing but to meet the needs of the present without compromising the ability of future generation to meet their own needs. So we have to look from the lightweight, corrosion resistant, ease of fabrication to energy usage, life cycle, and greenhouse gas emission. So eco-friendly means eco-friendly and biodegradable are not similar. Eco-friendly need not be biodegradable, and biodegradable need not be eco-friendly. The product can be eco-friendly but need not be biodegradable. Okay, So that means the material should be environmental friendly, eco-friendly, less hazard, so that the material can be used again and again, reused. So everything is cyclic. So everything is interlinked. Take example of the nature. So we all human beings and the animals gives out carbon dioxide. The plants take in these carbon dioxide and gives out the food and oxygen, which is necessary of life. So balance in nature is created because of this process. So if you look at this, the the sketch. So whatever we take, extract from the earth for producing something through manufacturing process, you can see we take something out of this earth crust, extract from earth, and we process it. After processing, we manufacture it. Okay. After manufacturing, what we do, we use it in our day-to-day or in industry, life or industry. Then we dispose it, it goes as a waste. So that is a closed cycle. Instead of that, if we look at the 4 R's, reduce, reuse, recycle, and regenerate. Okay, so with this, that constitute an open cycle. After manufacturing, or what we can do, we use it. After use in our day-to-day life as a product or in the industry, what we can do with after usage, we can do some reconditionings. That is nothing but some kind of modification or some minimal kind of repair things are done on that product. Again, we can manufacture it. Again, we can use it. Again, we can dispose it. So that constitutes an open cycle, keeping in mind the sustainability in aspect. So recycling is important. Okay. So I was talking regarding the biomimetics. Okay, this is very important and interesting thing in tribology, biotribology. So this bio means, as I told, living things. So a science which is biomimetics is a science concerned with the application of data about the functioning of biological system to the solution of engineering problems. So the natural things which are existing in nature, their process is copied by the engineers to solve some kind of engineering problems or day-to-day or tribological related problems. So biomimicry is a method for creating solutions to human challenges by emulating designs and ideas found in nature. It's used everywhere, building vehicles and even materials. Friends, you can see very interesting thing here over here. So the lotus plants, it grows in muddy waters. In maximum areas of West Bengal, besides the house, small pond will be there. I have seen this while traveling to IIT Kharagpur. Many houses, besides the houses, a small pond like are having these lotus in the ponds. So that grows in muddy waters, but it leaves emerge clean. So there is a mechanism behind that. So this design is mimicked, or a design can mimic form or shape, like a paint that helps surfaces self-clean the same way as a lotus self-clean. So this is copied so that self-cleaning property of the paint is obtained when it is done on some kind of wall. Okay, this lotus effect, what is this lotus effect? It refers to self-cleaning properties, so that are a result of the process called ultra-hydrophobicity. Ultra-hydrophobicity. So as exhibited by the leaves of Nelumbo, it is scientific name of this is Nelumbo, or the lotus flower. So the dirt particles are picked up by the water droplets due to the micro and nanoscopic architecture on the surface of the leaf. So this particular leaf, lotus leaf, has got some kind of different texture structure. So those micro and nanoscopic architecture on the surface, the water droplets falling on the leaves are absorbed, picked up by that water droplets, which will minimize the droplet adhesion to the leaf surface. Thereby, the leaf is left clean and green. Fine. So this is a lotus effect, a very interesting one. So you can see this, the super hydrophobic effect and self-cleaning property. Always it grows, the lotus grows in a muddy water, but always looks clean. So this is the texture or structure obtained when seen under SEM. So this is taken from Bhushan and Jung and Koch. They have made a detailed study or research study on this lotus leaves. Okay, again, further you can see at higher magnification the micro and nano, the nanoscopic architecture of this leaf, which will not absorb the water droplet, so that water droplets are not placed absorbed by this leaf. Okay, fine. So these are some of the, like lotus leaf, there are many other things in nature from which a human can copy, duplicate to solve some engineering kind of problems. Even in pitcher plants, water striders, butterfly wings, geckophytes. Okay, you might have seen the Spider-Man moving from here and there, moving from one building to another building. So that also involves such kind of thing. Shark skin, and even bird, peacock, and even moth eye, nacre of ablution shell, self-healing property on the body of or skin of human beings, sensory aid devices, ear and eye, spider web. All these things have these kind of biomimetics applications. So finally, what we have to do. So I have taken this slide, selected this slide to explain, because our STTP title is the advanced trending trends in advanced materials manufacturing and design. So whenever you engineers design a product or a process, you should see these things, keep in mind all these things. So make whatever you prepare, make and use it. It should be reusable and it should be remake. Again, you can with some modification, minimum modification, with minimum design. As you know, the different kinds of designs are there. The adaptive design, development design, the new design with some kind of a minor or major alteration in the product produced, recondition it, manufacture it. Again, you can recycle it. Again, you can make it. So this cycle should be continuous. So always the engineer should look or take these cycle into consideration whenever you design a product or process. So these are some of the important new offshoots or developments in tribology, tribo lubrication, tribo corrosion, tribo chemistry, tribo desorption, tribo reactivity, tribo layer, tribo mechanism, biotribology, tribo bioadhesion, tribo biocorrosion, all these things. So tribology is a tool to, tribology is very much related to environment. So as explained green tribology, if you take the other phase of the tribology, green word, green says many things to us. It shows happiness, it shows peace and calm, it shows many other things. Okay. So tribology is a tool to implement low carbon footprint materials into energy and resource efficient real system, like a lubricant which is non-toxic, harmful to the environment, does all these things. Okay. So I will go further. So this is all about tribology and developments in tribology and tribology related to environment. So people like you, research scholars and students of UG, PG and PhD students, after usually they develop material, they characterize materials, maybe mechanical properties, the microstructure properties and some other kind of properties. So tribological properties are not being tested for many of the materials developed. Okay, so the materials, whether it may be composite materials or alloy or any other kind of material, they are to be tested for tribological aspects. So tribo testing is very one of the interesting and most important thing in engineer should know. Every engineer should know. So tribo testing involves an experimental detailed interdisciplinary science in which testing plays a major role in the solution of technical problems for the development of tribo materials. So why this tribo testing is done? So one, tribo testing is done for to develop materials like lubricants or materials for research purpose. So this is tribo testing can be a research. If you develop a new kind of material, go for tribo testing. If it is having good hardness, good mechanical properties, you go for tribo testing. Okay, wear testing can be done so that you will develop a new kind of material which may find some kind of applications in day-to-day or in the industrial. It can meet the industrial needs. So by doing this tribo testing, you can find out the application of that product produced, whatever the product, the material you have developed. So you can find out the application where you can use that, the application part. One is the research part to develop a new material or to develop a lubricant. Another one is the application part, end use of the product. So that's why we need to go for tribo testing. So tribo testing is mainly concerned with friction and wear property evaluation of the materials. Okay. So there is no mathematical model which can be used in predicting the tribological behavior of materials and lubricants. Only one method is experimental based. Okay. And in view of this, increasing importance on the tribo testing to characterize the tribological behavior of materials and lubricants, we should go for the tribo testing. So what we can do after tribo testing, we can study the different working parameters. So we can gain a proper understanding of the wear processes, what kind of dominant wear mechanisms are operating at different wearing conditions. So we can characterize material for particular type of applications where it can find its end use, for ranking them in order of the functionality, to check whether the machine parts work as per the design or as per our need, improvement or replacement or improving system design for longer part life. Fine. So these are the aims of tribo testing. So this is parameter influencing the tribo testing. That involves, tribo testing involves finding out the wear and friction. So material parameters are affected, design parameters are affected, environmental parameters are affected, and lubrication parameters are affected. Concerned to material parameters, its composition, what composition it is made up of. The microstructure you can do study, the mechanical properties, the thermal conductivity, the degree of work hardening. Design parameters, shape of the specimen, loading, what kind of loading, type of motion, whether it is sliding motion, rolling motion. The surface roughness also determines the friction and wear, the vibration and cycle time. And even the lubrication test. So there are two kinds of wear testing done, or the tribology test is done. The dry testing and the wet, the using lubricants. So the type of lubricant stability and type of fluid lubrication is also affecting, influencing friction and wear. And environmental factors like the surrounding things like temperature, the humidity, wet or dry conditions, and the contamination in the lubricant. So these parameters are to be taken into consideration while we do tribo testing. So tribo system and its characteristics. I will not go in detail about this. Already I explained the parameters affecting friction and wear. So for tribo testing to be done, for testing, tribology testing, for wear testing, we need to have friction pair. That means we need to have a specimen, tested specimen. If you develop a material, you need to develop a test specimen which is as per ASTM G90 standards. There is a standard ASTM. Accordingly, you can select the sample size, and there should be a counter specimen that is called as a counter phase. If you are doing under dry conditions, you need not to have a lubricant. If you are doing under wet condition, you need to you can use a lubricant. A third body can be present, and the surrounding, the atmospheric air, okay, that is affected by the ambient air, the humidity, and other conditions of the environment. Okay, so what you are going to get out of this tribology testing are, you are going to get the frictional force when there is contact between the two surfaces in question. When there is a motion between the two surfaces, then there occurs a friction. You can measure the friction. When there is continuous motion or sliding, rolling, or whatever the kind of motion is there, when contact occurs between the two surfaces, then there is loss of material because of the relative motion occurring between them, because of the sliding motion or whatever the kind of motion, then there occurs wear. You can measure the wear. So you can take the texture. I can study the texture of that surface worn. Okay. So the different parameters which can be controlled. Yeah, on the left hand side, I have shown the type of motion. As I told, it may be sliding motion, it may be rolling motion, or any other kind of motion. The speed we can control. We can apply different kinds of load on the machine. Even with we can conduct the test at room temperature or a higher temperature. You can control the duration of test for 1 minute, 10 minutes, half an hour, 1 hour. Okay, you can control all these parameters during Tribo testing. And uncontrolled parameters are heat, which is generated in between the two surfaces of the sample as well as the counterface. The wear debris is developed during the test, and the vibration produced because of the test. So the undesirable outputs which are occurring due to the Tribo testing, the vibrations, the residual wear debris, and the heat. Okay, fine. So let's say the categories of Tribo testing. The Tribo test can be classified as simulation tests in laboratories and bench test under practice-oriented condition, that is experimental based, field test under practical operating conditions. Okay, so the first two, simulation and bench tests, are used for preliminary screening and study of materials or designs at a laboratory. Field test is a different one. So what is done? Tribometers, for Tribo testing, we are using tribometers. Okay, so Tribo materials, Tribo testing is done for new materials like ceramics, maybe composites, metals, polymers, using lubricants. Even the lubricants and oil additives can also be tested using these tribometers. Self-lubricating systems, and this is done for quality assurance. So for carrying out the experimental work for the Tribo testing or wear testing, as I told you, sample preparation, I mean the sample is to be prepared as per the ASTM G1990 standards. So initially samples of proper dimension as per the standards of ASTM are prepared as per the size, machining after machining. Okay, as the quality of is affected by surface finish, that is also taken into consideration. For that, using silicon carbide polishing paper, C400, C1000, C1500 grit sizes, polishing is done on the surface of the sample. Finally, the samples were mirror finished by using 0.5 micron alumina suspension with water using cloth grinding instrument. So there are different methods available for sample preparation. Sample preparation is very, very, very important for Tribo testing. Okay, so I have taken this simple example. So there are different methods of wear testing. So one is weight loss method. So here what is done, an analytical weighing balance, digital weighing balance with a precision of 0.0001 gram is used to measure of the pin. Pin means sample. Whatever the pin, in this slide I have shown you the sample preparation, that is a pin preparation. Maybe as per ASTM G99 standard, a pin of size, cylindrical pin of size 32 mm length with 10 mm diameter with polished at one end is prepared. So that can be tested in a Tribo testing machine, that is called as pin on disc wear testing machine. Before testing, weight loss method, before testing, the weight of the test pin is measured, and after the test is done for with the application of a particular load with the movement, I mean the sliding distance and with the sliding time, after the test the sample is weighed. The difference between the initial weight and final, I mean the final initial weight and final weight gives the weight loss of wear rate. That is one method. That is called as weight loss method. The second one is mechanical gauging method. That is used by specimen displacement using LVDT, which is present on the tribometer. That is height loss method. The first one is weight loss, second one is height loss. The third one is optical method, reduction in size of an micro hardness indentation taken on the surface. The most commonly used and easier method is weight loss method used by researchers, scientists all over the world. Okay, so the suitability of the materials are tested for wear rate. I mean, by using this Tribo testing, what we are doing, we are measuring wear rate, the frictional force. We can find out the wear mechanisms. Wear mechanisms can be found out by observing the worn surface under optical microscope or under scanning electron microscope. So whatever the weight loss, I mean the material loss occurs due to movement of pin over the sliding surface counter body. So the debris are produced, small particles are taken, they are collected in a piece of paper and kept in a box. Those are taken for SEM studies, scanning electron microscope studies. Their size, shape and other things are analyzed to study the different kinds of wear mechanisms operating at different wearing parameters. So wear studies are conducted at room temperature and at high temperature. That means at room temperature, normal room temperature, and at high temperature means the test sample can be heated at different temperature, 50 degree, 100 degree, 150 degree. Likewise, the less than the recrystallization temperature. So even the wear mechanism maps can be drawn by considering the various wear parameters and the dominant wear mechanisms operating at different wearing parameters. Maps are drawn by which we can find out the dominant wear mechanism operating at different wearing conditions. Even with the applications of some kind of lubricants and additives, we can study the wet, we can study wear, we can conduct wear tests at under wet conditions also. So these are the different ways by which the suitability of the material can be tested by using the Tribo meters or Tribo testing. So friends, these are some of the SEMs which are taken after wearing, at different wearing parameters, after sliding for a particular sliding distance at a proper normal load and at sliding velocity. You can see different wearing mechanisms operating. So these continuous grooves formed, they are called as abrasive mechanism, continuous parallel grooves, and discontinuous parallel grooves can also be seen at some places here and there. So those, that is called as a three-body abrasive wear, and continuous grooves that is called as a two-body abrasive wear. Okay, so somewhere more material loss is there. So the peeling of the material, we can see, you can see some pits, and you can so that is because of the, what do you say, the delaminative wear, and more detachment of material takes place, loss of material due to the loss of properties in that particular condition of what do you say, the wearing parameters. So these photographs are for A356 alloy with TiB2 particles with different weight percentages, with 0% weight, 2.5%, 5% and 10%. So this is the work carried out by Mandal et al. Okay, so this is the SEM photo micrographs of the wear debris at different wearing parameters. So wear debris of A356 alloy with the TiB2 composites at different loads, 19.6 Newton and 78.4 Newton with a different percentage of this TiB2 particles. So this is, you can see large flaky particles, small wear debris. Okay, oxide layer formation with some kind of iron oxide is also there, which acts as a mechanically mixed layer, preventing metal to metal contact surface between the pin and the, what do you say, the counterface, leading to lesser wear or more wear resistance. So for tribology testing, tribology research facility is required at your lab. Suppose you want to conduct tribology testing for the developed material. Okay, so you have done some kind of casting, by using some kind of casting, say star casting, you have developed a composite material. After that, you will study the microstructure of that. If there is, after that, you will study the mechanical properties. If there is any kind of improvement in the mechanical properties like tensile or hardness, and there is improvement, then you will go for the wear properties also. For the wear properties to be checked, you need to have the standard equipments as follows. So one is pin on disk machine. This is called as POD, that is computer controlled machine. Usually in our India, Ducom Private India Limited is Bangalore. It is a company which is supplying these manufactured tribometers to industries as well as research centers, to organizations and educational institutions. Ducom Industries Private Limited. So they will supply pin on disk machine, that is computer controlled pin on disk machine. This normal pin on disk machine can be used to test the materials at room temperature. So if you want to test the materials at different temperatures, you can go for high temperature pin on disk machine with computer controlled facilities. So you need to have a metallurgical microscope for observing the worn surface after the test is conducted. You may need to conduct scanning electron microscope study, SEM studies, which you may not get in your colleges or R&D centers. Usually NITs, IITs, and big organizations have that SEM, XRD, and TEM facilities. So chemical polishing machine can be purchased. It doesn't cost much. And a high-speed sample sewing machine cutting machine can be purchased. And even surface roughness measuring instrument can also be purchased. Mitutoyo Japan instrument available at minimum cost. And even chemical analysis of the samples done can also be done with different kinds of instruments. Metal cutting machines are required. And even you need to have foundry lab, whether you are doing experiments or the developing material, whether it is a ferrous or non-ferrous type, depending upon that, you can have the kind of foundry lab with a different induction furnaces, electrical resistance furnaces, muffle furnaces, and for heat treatment, and different kinds of furnaces as per your requirement of testing. So other equipments required are broad range of facilities to study the micro hardness and other material properties. As I told, after you develop the material, kind of material, suppose take example of you develop a composite material or some other kind of material alloy. So you will be testing the mechanical properties using tensile testing machine, and micro hardness or hardness testing is done by using some kind of hardness testing machine, which is a machine supplied by Microtech Industries Private Limited from Pune. Even you can have atomic force microscope, that is a costlier, available in NITs, IITs, and big organizations. Environmental SEM incorporating EDS and WDS, and these can be used for further studies. EDS identifies the elemental composition of materials imaged in SEM for all the elements at an atomic number greater than boron. So WDS can also be used along with the SEM. So wavelength dispersive spectrometry, that is called as, along with XRD, X-ray diffraction can also be done. So to find out the elements and the amount of elements present in that kind of material study. So Tribo testing is done by using different types of Tribo test pairs, like ball or pin on disc machines, 4-ball tester, rubber wheel abrasion, and erosion test, scratch test, reciprocating rig, trapping torque, and pin in V blocks. Okay, so methods used in development of testing methods are machines are, so the input parameters are varied, like what you can change is the load, normal load, radial or axial load. You can vary the normal load, or normal you can consider or calculate in terms of normal pressure also. So the type of load applied can be dead weight with the help of pulley, pneumatic, or hydraulic, or motorized. Okay, so the speed can be varied with the help of a machine that is provided. So the temperature can also be varied in case of if it is a high temperature pin on disc machine. The duration, that is a time, that means that constitutes sliding time or sliding distance. Okay, so the environment, it can be lubricated, taking into consideration the humidity. It can be done, the wear testing can be done in an inert gas atmosphere, or it can be done in a vacuum or in an open air at room temperature also. Okay, so such kind of varying wear parameters can be considered while you conduct the tribology testing. Okay, so sliding wear test, as I told, pin on disc is there. The first one, pin on disc, the pin is fixed in a lever, and the disc counterface, which is made up of EN31, EN32 steel disc having different composition, is made to rotate at some speed for a particular duration of time. So you can conduct the conduct room temperature test without heating the pin. You can conduct the test at a different temperature at 50 degree, 100, 150, 200 degree, depending upon the type of material and applications. By heating this pin, the temperature of the pin can be tested with the help of the monitor, as well as by making a pin hole at the bottom of the pin, by using a chromal anomal type K-type thermocouple. The second one is block on ring test and sliding 4-ball test. All these things can be used for sliding wear tests. So you can see pin on disc type as per ASTM G99 standards. As I told, a pin is fixed in position in a lever or in a holder, and a counterface which is made to rotate at some speed for a particular duration of time. So this is ball on disc. This is pin on disc. This is ball on disc. You can see this machine. So a counterface, a disc is there, which is made to rotate, connected to a motor at some speed for a particular duration of time, and there is a lever connected to LVDT with a sensor and a motor. So that is held in position, fixed in position. Okay, so this monitors wear and friction in sliding contacts, whether it is dry or lubricated. So there is a PC connected and a monitor is there, which gives the friction and wear values, which can be noted as and when required. So both dry and lubricated test can be conducted. So wide range of speeds can be adjusted to conduct at a different speeds, sliding velocity, what I mean to say. So again, you can see pin on disc as per ASTM G99 standards. So this is a rectangular pin instead of a circular pin taken, and a revolving disc is there. You can see a closed chamber which can be heated or which can be supplied with a gas, inert gas. The test can be conducted under an inert gas atmosphere, or even can be conducted in a vacuum. Okay, so this is a pin on disc machine controller which gives the value of a wear, which gives the value of a frictional force. You can set the speed, you can set the speed, and you can set the sliding distance by controlling, setting the time. Okay, so power on off facility, start stop facility is there. Okay, you can set the RPM knob is there. So this is the control panel on the front side, back end side, sorry. So pin on disc tribometer, it can be used for studying the wear properties of a material under dry or lubricated condition at various varying parameters at ambient or under vacuum conditions. Metals, polymers, ceramics, plastics can be tested by using pin on disc tribo testing machine. So this contains machine, a controller, as I told. Machine contains a disc holder, LVDT, load cell. Controller content control to set a speed and test duration, as I explained in this front side control panel. Okay, there is a data acquisition system, lubrication unit is there. So all these things you can see clearly. Sample size you have to select initially. This is as per ASTM G99 standards. Sample size taken is 32 mm. This is a sample. 32 mm length with 10 mm diameter. This is a VR pin or sample. Disc material. This is the disc material having a composition of 0.9% carbon, silicon, manganese, sulfur, chromium, and balance iron. So this is called as EN31 steel. It is also having dimension of 165 mm diameter and 8 mm thick. It is having a hardness of HRC 61 and it is having a surface roughness of 0.47 to 0.87 micrometer. So this is an example of high temperature pin on disc arrangement supplied by Ducom TR20M35. So you can see this, the machine which is used for high temperature pin on disc wear testing. So again, the schematic diagram of this is shown. Here you can see the closed chamber in which the heating of the sample is done. The bottom one is a disc. Okay. So here you can see this handle. This is connected to LVDT. Okay. Frictional sensor. So scratch testing is also done by which we can find out the wear properties of the material. This is the machine. So Sandeep sir, Ghosh sir.
Yes, sir.
Yes, sir.
Yes, sir.
I can take another 5 minutes. Time is
Yes, sir. Yes, sir. Yes, sir. You may continue, sir.
Another 5 minutes I will take, 5-10 minutes.
Okay, sir.
So this table shows the various wear parameter studies. You can select this first column as the composition of the alloys or the composite what you have produced, material you want to develop with various composition. I have shown the various percentage of silicon added to LM25 alloy, that is A356 alloy and LM6 alloy. Okay, before and after the addition of master alloys of aluminum 3 titanium, aluminum 3 boron, and aluminum 10 strontium alloys. So the various wear parameters which can be varied are load, that is called as normal pressure, sliding speed, velocity, and time, sliding distance. So you can choose the values with using the formulas, and you can keep if you varying the normal pressure, you can keep the sliding speed and sliding distance as constant. If you are varying the sliding speed, you can keep the load and sliding distance as constant. If you are varying the sliding distance, you can keep the normal pressure or load and sliding speed as constants. With this table, you can conduct a test on any kind of material to test their tribological properties. This is one 4-ball tester used to test lubricants and cutting fluids for different extreme pressure property, wear properties. This is air jet erosion tester. This is dry abrasion tester. Okay. So this is nano tribometer available at IIT. Okay. And even at some CSIR labs. So these are the wear tests done as per standards of ASTM, ASTM G132, ASTM G105, likewise. So these are the wear mechanism maps. These are the wear mechanism maps drawn after the wear testing is done, after the calculation is done, after the dominant wear mechanisms are studied by using various wear mechanism operating at various wearing parameters, after studying the wear debris, after studying the SCM, after drawing the graphs. Okay. So very interesting area. Not much people have done work on this wear mechanism maps. You people can take this drawing of wear mechanism maps. So this is a very interesting area. We are testing and drawing wear mechanism maps. So finally, I would like to conclude. Systematic tribo testing is extremely important in characterizing tribological performance of materials and lubricants. Due to the absence of worthwhile theoretical models in tribology, tribo testing will continue to play an important role in tribological research and industrial problem solving. So these are some of the references from which I have taken the things. So I would like to extend my wholehearted thanks to my my guide, Dr. S.A. Kori, who is the present Vice Chancellor, Central University of Andhra Pradesh, and all other my PG guides and my mentors and my co-guides and all other my friends, all my teachers and staffs. So thank you. So finally, I would like to conclude with this slide. Dear friends, to lead a comfortable life and to be happy and successful, if you want happiness for an hour, take a nap. If you want happiness for an hour, take a nap. If you want happiness for a day, go for a picnic. If you want happiness for a week, go for a vacation. If you want happiness for a month, get married. If you want happiness for a year, inherit wealth. So finally, if you want happiness for a lifetime, learn to love what you do. Most of us are teachers, many students who are still learners. So feel happy what you do. Learn to love what you do. So with this, I conclude. Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you,
Thank
sir.
you.
So any questions from the...
Okay.
Dear participant, if you have any question, then you may ask. Dear participant, if you have any question related to this area, then you may ask.
Any questions, dear delegates?
No, sir.
Say, I think most of the participants are students only, maximum 90 to 95%. The quality of a good student is to ask questions. That is called as a scientific temper. So, a scientific temper involves always you remember. Finally, I would like to say this word. You should have in your mind why. Why question should be there. Why, how, where, when, what. So these things should be there in a student, these qualities, these questions. Then only
Thank
you
you.
are a perfect student.
Thank you, sir. Thank you, sir. Really, sir, session was very, very interesting and informative session. So our students will be benefited. You have discussed so many things. Idea behind tribology and its application, tribo testing, aim of tribo testing, parameters influencing friction and wear, categories of tribo testing. So really, sir, session was very, very interesting and informative. Thank you, Dr. Prabhudev MS, sir. Thank you, sir.
Thank you, sir. And
I
Thank
think
you, Prabhudev,
students
sir.
from mechanical background are attending this.
Sir, yes, sir.
maximum are, sir,
Maximum are
mechanical.
from mechanical and some of are, sir, other branch, sir.
Okay. Dear students, freely you can ask, you can discuss with me now. And some more things I would like to tell you regarding the Tribology Society of India is there. That is one society who is devoting its time for the development of this tribology related areas. So just I would like to share for another 1 minute, if you permit me, Ghosh sir.
Yes, sir. You may continue, sir.
Just for 1 minute,
Yes.
I would like to share that. Is it visible, sir?
Yes, sir.
Yes,
It is
sir.
visible, sir.
So these students, participants, Tribology Society of India, more popularly known as the Tribology Society of India. So this society has dedicated, devoting its time for the correct tribological practices to protect and enhance the life of plants and machinery, improve efficiency of operations. More than 30 years with its historical background, it's conducting many workshops, international, national conferences. There is a website available if you search in Google. Okay, so there are many local chapters of a Tribology Society of India is there. Every year in the month of June, they will conduct one summer research tribology that is free of cost. So those faculties who are involved in research and other things, academic activities, they can join that free. No registration fee is there. You can first initially you can become a member by paying some amount of fees. So these are some of the aims and objectives of the Tribology Society of India. So you can join initially. You can join as a member, lifetime member, by paying around 2,500. I don't know. Presently, it may have increased the registration fee. After becoming a member, you can attend the conferences, summer workshops. Summer workshops, they won't charge you if you are a lifetime member. Conferences, they will give you some kind of some amount of discount, some percentage of discounts, and even you can publish your research work in the Journal of Tribology, published by Tribology Society of India. It is a national journal. So now presently Satish V. Kailas sir and some people from IOCL, Indian Oil Corporation Limited, are heading this Tribology Society of India. Many people from industries like BHEL and many R&D organizations, CSR, and even international organizations are involved in Tribology Society of India. Recently, they have conducted Tribo India 2021 international conferences in New Delhi. It was in online and offline mode also. And even International Tribology Research Society symposium conducted in the month of December. It was a symposium. More than 295 papers have been presented. Dr. Jitendra Kumar Katiyar from SRM Institute of Technology, Chennai, was the convener and coordinator for that ITRS 2021. So people like you, young people, research scholars, can involve, present, discuss the latest developments in the tribology related areas. So I request you to become part of this TSI, Tribology Society of India, by paying some registration fee to become members and take benefits, free benefits like attending free workshops. So it's a very good workshop conducted in a very professional manner. They provide you star facility accommodation with eminent speakers in a very good atmosphere. So even faculties can also join. Many people from West Bengal are involved in this Tribology Society of India. So with this, you have some journals related to tribology. If you do some research work on tribology, you can publish your work in these listed journals. Okay. So these are some of the major tribology related conferences. Fine. So with this, I would like to thank you. Thank you once again.
Thank you, sir. Thank you, sir, for making an excellent presentation and making a session is meaningful and interesting, sir. And also, behalf of the organizing committee and the audience, also I thank I thank you, sir, for your valuable information and share with us. Thank you, sir. Thank you, sir, and thank you, SC Vishkarma, sir.
Thank you, sir.
Thank you, sir.
Vishkarma, sir. Thank you, sir.
Ravani, sir.
Yeah.
Just a minute.
Yes, sir.
Let me thank you, sir. Mahadeva sir, Prabhudeva sir.
Yes.
He was, his lecture was so much interesting for me, at least, because I being in the industry, I never had been to the testing side.
Yes, sir.
I only practice the tribology in the industry.
Okay, sir. Okay.
So this was very, very good and good exposure to me also. So thank you very much, Prabhudeva sir. And
Thank you,
I
sir.
would like to have your number so that I'll get connected to you.
Sure, sir. Sure, sir.
Because
Sure,
you see, at one time, Institution of Engineers had actually conveyed the 2 days TSI programs, wherein I was invited as a keynote speaker. So
Okay.
TSI's program, I used to go there because it's a very, very interesting program
Yes, sir.
wherever it is happened. So please share your number to me, maybe
sir.
through Sandeep sir, or maybe through Ravani sir or Subrata Bose sir,
Sure,
so
sure.
that I can get connected to you. Thank you so much, sir, for this your session, and it
Sure,
was very much, very much giving input and insight of the tribo testing. So that was
Thank you very
interesting.
much for joining this session and giving me input, sir. At least you have given me feedback, or I'm happy. Actually, I expected some questions from the students, but they are quite. Even at the end of your session also, they were quite. Even at the end of my session also, they are quite.
Yes,
But,
sir. Only because
students should involve.
Yes, I would request all the professors of mechanical engineering department to at least when they are taking class for design, they should also take at least 5-6 classes on the tribology, because it covers the material. During my days, material was one of the paper, but now that material science has been removed, so material, they don't know the material actually, and the the manufacturing processes comes later. You have to first understand the material, then manufacturing process, and there are different methods of developing the required surface, sir, with required micro hardness, required the microstructure, everything. So they need to understand this. They need to understand the lubrication. In chemistry paper, I suppose in second year or first year, second semester, there was a paper, industrial chemistry. Now that the paper is removed, or maybe the lubrication was one of the major chapter, water and lubrication. I don't think that chapter is there, because otherwise these students might have exposure of lubrication and lubricating things and tribology at least. So I suppose because these things are not in their curriculum covered, they are new to this subject, I suppose, and that is the reason, one of the major reason, I suppose, they are not asking any question. But my request to all the faculty of BCT to look into this aspect, because this is very, very important area, and researchers have plenty of scope to do in, whether it is a micro tribology or nano tribology, or you talk about anything. Even yesterday there was a talk on the friction stir welding. There also the tribology is there. So you have to expose the students so that they get idea and interest in the subject. So that is my request from my side. Thank you so much. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir, and welcome, sir. Thank you, sir.
Thank you, sir.
Soon we will meet and discuss, sir.
Okay.
Sure, sir. Sure, sir. Sure, sir.
Thank you,
Sure.
sir. Good day to all, sir.
Oh, okay. Thank you, sir.
Bye.
And
Thank you, Mahadev, sir. Thank you, Dr. Shankar Chandra Vishkarma, sir. Also,
I'm Prabhudev. Mahadev is my son's name. Actually, I logged in with his
yes, sir. Yes.
account. Fine,
Okay,
anyhow.
sir.
Right, sir. Right. Namaste, sir. Namaste. Thank you.
Okay, namaskar, sir.
Okay, sir.
Namaskar.
Namaste, sir. Namaste.
And Bigam, sir.
Yes, sir. Yes, sir.
Uh,
So,
all the
dear
stu-
participant, next session will be started from 2 p.m. onward.
yeah.
2 p.m. onward. So, all of you again join next session 2 p.m. sharply. Thank you.
Ravani,
Okay.
sir.
Yes, sir.
The next session will be on the same link or the other link?
No, same link, sir.
Oh,
Same
only
link.
validative part will be on the other link, right?
Yeah,
yes,
sir.
sir. Yes, sir.
Okay. Okay, sir. Thank you.
Okay.
Okay. Thank you, sir.
Thank you, sir.